Hi friends, so we're continuing on with this particular example. So we're going to go through and simplify square root of 75. So let's see what we can plot of 75. That is 3 and 25. 25 is a perfect square. So this gives us square root of 75 is square root of 25 times 3. Square root of 25 is 5. Oops, definitely don't need the radical sign. So after you take the square root, then you don't need the square root symbol anymore, which is me starting to write 5. But we do need that for the 3. There's that one. All right, 98. 98 is 49 and 2. So that's going to be the square root of 49 times 2. Square root of 49 is 7. 7 times square root of 2. Notice I'm kind of skipping a step here as you get to that point. Feel free to do the same, but you want to make sure that your instructor knows where you're pulling everything from. So then we have square root of 200. Now, the square root of 200 is 100 doubled. So that's going to be 200, 2, and 100. So that's going to be, oh, I'm sorry, I was off the page. Let's just move the camera. There we go. It's going to be square root of 100 times 2. That's going to be 10 radical 2. Next row, we have 96. This one I might need to grab. I think this might be 16. Let me double check. 96. 96. Yep. So 96 gives us 6 and 16. 16 is going to be my largest perfect square. So then I have square root of 16 times 6. That's going to be 4 radical 6. 54. Oh, let's see. 54. I think the largest one is 9. 54. Yep, I was right. And 9 times 6 gives us 54. So that means, oh, I forgot to draw my factor tree down here. And 9. So that means then square root of 9 is 3. This gives me 3 radical 6. Soon we're going to be talking about what we do when we have similar ones. We can actually do some operations with them if we're trying to combine them. The negative sign out in front, all that does is just keep a negative in the answer. Know that it's negative and it's outside of the radical. It's not inside, so that's important to note. When it's inside, it actually means something else. So 80, let's see. I think that's 4? No. Nope, there's a larger one. 16, there we go. And then 5. So again, the negative sign stays out in front. So just like we've been doing. And then 16 times 5. So then we're going to split up. I'm going to show all the steps on this one because of that negative. So we just pull out that negative that just stays in front the whole time. So that's it. So we have negative 4 times the square root of 5. So nothing special beyond that. When you have a negative that you're multiplying, same idea. You just bring it out in front like normal. I feel like we have done 120 so far. Nope, okay. Let's see. What goes into that evenly? Is that 16? Nope. Yeah, so 120 is 4. I thought there was a larger one. There's not. This is what's weird is that what's left over is actually 30. Now, there isn't a perfect square that goes into 30. A lot of students get confused. They think that 30 is a large enough number that it should be. But it's just 2, 3, and 5. That's it. So there's not a perfect square that goes into that. So now we have negative 3 times square root of 4 times square root of 30. Negative 3 times 2 times square root of 30. So this is going to be negative 6 times the square root 30. And then my habit is to box them. So I apologize. I'm not circling them like the instructions say. All right, the next one's 320. So 320. Oh, trying to remember which one this is. Nope. 320. Yep. All right. 320 is 64. Again, all I'm doing is just going through and checking these. Not doing anything special beyond that. So 320. So 64. And then 5. So then when we split this up, we have 5 times square root of 64 times the square root of 5. So that's going to be 5 times 8. And 5 times 8 is 40. So this is 4 times the square root of 5. 147. This one I usually mess up on. 147. So I'm going to go through and just check a few. So 147 divided by... Aha! It's 49. 147. 147. Come on, Mr. Drummond. So 3 and 49. All right, so now when I split this, I got 4 times the square root of 49 times the square root of 3. So 4 times 7 times 3. 4 times 7 is 28. So that's 28 times the square root of 3. Oh, look at me boxing these. Old habits die hard. Always. I always box my answers. There we go. Circling. All right, so now this one's just a few more steps with these radicals here. We actually take and we square root each part, the numerator and the denominator. So we take the square root of 49 and the square root of 64. Square root of 49 is 7, and the square root of 64 is 8. So we are done, and that is it. That is all you need. I boxed it. I also circled it. Whew. So that's all you need to do for these. You don't need to do anything more beyond them. And you notice that in the denominators on all of these, that they're all perfect squares. That's intentional. If they're not, there's more steps you have to go through, but we don't do those until AG2. So just kind of a heads up on that. So here, the denominator is going to be 9. The numerator, though, the square root of 81 is 9. The numerator, that 40, again, we're going to see, all right, what's my larger perfect square that goes into that? And it's 4 with 10 as a remainder. So 10 is my leftovers. So that's going to give me, so the square root of 40 is going to be the square root of 4 times the square root of 10. So that's going to be 2 times radical 10. And that's my answer. So for this one, I have 2 times the square root of 10 over 9. And there I circled it. Then for this last one, again, 3, and then square root of 3 over the square root of 100. Square root of 3 is just square root of 3. It doesn't simplify. There's not a large perfect square that you can pull out. And then we got 10 for the square root of 100. And then we are done. Good luck on your notes or on your examples. If you need questions, reach out to your instructor. Have a wonderful day.